His Uncle Frederick taught Carl about numbers. He taught Carl how to write. Frederick picked up a stick and drawn a straight line and then a curvy line in the dirt. Here's the 1 and the 2. It looked as if Frederick was drawing the shapes in some kind of order. Then he read the list to Carl. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then stopped and corrected himself. No, Carl, I should have started with 0. And he drew his circle. So now the list is complete. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. What is 0? Carl said. 0 is the number of nothing, said Frederick. Carl was not intimidated. He already knew most of what the teacher was teaching. And if he hadn't known it already, he learned it easily and quickly. No one had to tell him anything twice. Penmanship was an important part of the basic education of the day. Although writing with the quill is difficult, Carl mastered it quickly and well.
Gauss's teacher wanted the boys to be quiet one day, so he asked the boys to find the sum of the first 100 counting numbers. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, ... plus 96 plus 97 plus 98 plus 99, 100. The other boys were quickly to start at this enormous chore. Adding 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, 15 plus 6 is 21. This was going to take them a long time. The teacher and his whip were ready to straighten out any boy who gave up. Carl used a different approach. Rather than starting in it immediately, he sat and thought for a minute. Then he wrote an answer on a slate and walked to the front of the room and put it on the teacher's desk. After an hour, when all the other students were finally finished with their slates, they also put them on the teacher's desk. The teacher began to check the slates. One slate after another, the answer was wrong, until he got to Carl's, who had the right answer, 5,050. The teacher wondered how Carl had gotten it. He had spent no time on it. It hadn't done any figuring on the slate, and it looked suspicious. He demanded an explanation. Tell me, boy, how you got this answer. Well, sir, I thought about it and realized that these numbers were in a row, and that they were consecutive, so I figured there must be a pattern. So I added the first number and last number, 1 plus 100 equals 101. Then I added the second number and the next to last number, 2 plus 99 equals 100. It started to make sense that 3 plus 98 would equal 101, and 4 plus 97 would equal 101. If I continued adding pairs of numbers like that, I would eventually reach 50 plus 51. This meant I would find 50 pairs of numbers that always add up to 101. So the whole sum must be 50 times 101, which equals 5,000. Carl and Martin wanted to prove the fifth parallel postulate through any point that is not on a line. It is possible to construct only one line parallel in the original line. Logarithms were the only practical way to do multiplication of large numbers before the invention of a handheld calculator. Because logs were a constant companion to him, and by the time he was 20 years old, he had mastered most of them. The Duke also instructed Zimmermann to provide Karl with a set of drawing instruments, including several compasses and a finite brass straightedge. A real challenge for Karl at the gymnasium was learning German. Sometimes it was only a question of punctuation, but other times the words were completely different.
The prime number theorem describes the asymptotic distribution of the prime numbers. The prime number theorem gives a general description of how the primes are distributed amongst the positive integers. It formalizes the intuitive idea that primes become less common as they become larger.
I can construct a regular polygon with 3 sides, in other words, an equilateral triangle. I can construct a regular polygon with 5 sides, in other words, a regular pentagon. I can construct a regular pentagon with 17 sides, as I just did here. I could also construct a regular polygon with 257 sides, although fitting it in one piece of ordinary paper drawn to any scale that would be visible would be difficult, to say the least. I could also make a regular n-gon using my multiple of Fermat primes if I wanted to, like a decan of 15 gon and a 34 gon. The only limitation is that the Fermat number n that I start with must be prime. Now that Gauss saw himself as a growing mathematician, he adopted the motto for himself, few but mature. He devised a seal as well, showing an apple tree with 7 large perfect apples. The motto and seal symbolized his determination to publish his mathematical discoveries only when they were perfect. In 1796, Gauss wrote an announcement of his discovery of the method of drawing a 17 gon using only a straight edge and compass. He sent it to Zimmermann back in his hometown with a request that Zimmermann could please publish it. Zimmermann was impressed and immediately sent it off to a journal to be published. The publication established Gauss as the discoverer of his technique, and it alone was enough to guarantee that Gauss was considered one of the greatest mathematicians. The 17 gon was only the beginning of an amazing career in mathematics. Gauss was only 18 years old when he discovered it. Because Gauss's only assumption was that it had to be an ellipse of some sort, his only challenge was to find the ellipse that matched the 24 siding. Once he discovered the formula, he sent it to several astronomers, and his prediction was announced to be the astronomical community in the monthly correspondence. Although the weather made it impossible to confirm his figures immediately, when the skies finally cleared, Crees was discovered in December 1801, exactly where Gauss's formula had predicted. Gauss was an instant celebrity. He was immediately elected a corresponding member of the St. Petersburg Academy of Sciences and invited to come to St. Petersburg, the capital of Russia. Olbers decided that it was important to help Gauss get a good position in astronomy in Berlin, and he worked behind the scenes to help. He saw his work as more urgent when he learned that St. Petersburg in Russia had offered Gauss the directorship of its observatory. Although Gauss was happy to let Olbers work on a position in Berlin for him, in fact, he never accepted it, nor did he accept the position of St. Petersburg. It took 40 years before the methods that Gauss explained in the theory of the orbits became the standard method for calculating orbits of planets and comets. But over time, astronomers came to agree that it was the best method. Soon after its publication, Gauss was showered with honors from everywhere. An example is, let's consider the case n equals 7. In routine, to check it, 3 is congruent to 24 mod 7, negative 31 is congruent to 11 mod 7, negative 15 is congruent to negative 64 mod 7. Because 3 minus 24 equals negative 3 times 7, and negative 31 minus 11 equals negative 6 times 7, and negative 15 minus negative 64 equals 7 times 7. During the last period of his time before 1841 to 1855, Gauss spent much of his time on pure mathematics, particularly analysis and functions of complex variables. His last scholarly work was his fourth proof of the fundamental theorem of algebra, which he had first proven in his doctoral dissertation in 1799. He also pursued his astronomical observations and was one of the first people to observe the planet Neptune, soon after his initial discovery in 1846 by Galilei, one of Gauss's friends who had told him of his discovery before publishing it. When Gauss died in 1855 at the age of 77, he was a very wealthy man. His basic salary of 2,500 thalers, plus any fees to be received from his students, and the 110 thalers he was paid for his role as assistant director of the Royal Society of Sciences, should not have yielded an estate of 152,892 thalers in bonds, plus the 17,965 thalers that were found stashed in various places in his home.
Yet there is no question of his honesty. He was a frugal man with a wise investor. He used the same genius in conducting his private finances and then applied it to his mathematics. Gauss said when he dies he would like to have a regular 17 gon carved on his gravestone. Like Archimedes, the Greek mathematician of antiquity had discovered a sphere that fits perfectly inside a cylinder, has exactly 2/3 its volume of the cylinder. He had asked to have a drawing of this great discovery carved on his gravestone. Gauss did not get his 17 gon on his gravestone because the stone carver refused to carve it, saying that people would think that he had been trying too hard to carve a circle. He had too much pride in his work to do that.